Hello. Yes, sir. I'm available now. So shall I start, sir? Hello. Yoga, sir, shall I start? Okay. Thank you, sir. So, very good evening, everyone.
Good evening, ma'am.
Yeah, good evening, sir. So, I think this is the last session. So, I welcome you all in the last session of this 5 days FDP. Today is the last day where I'm going to discuss the last concept, that is correlation and regression using Excel. And then, if time permits, we'll see some of the situations, some of the caselets where you need to read the situations and to tell me in the particular situation which is the appropriate test which we can apply on. Right? So probably you will get some exposure if some situations are coming, or maybe in your research work if you are doing such kind of thing. So which is, or in how, which way you can identify that this test will be suitable for you to apply on. Right? I have shared the Excel sheet today, which we are using for the analysis purpose. So I hope everyone has downloaded it. Yes. Please confirm. Have you downloaded the sheet?
Yes, ma'am.
Fine. Biswas ma'am, where were you yesterday?
Actually, I got call letter from Delhi IIT. So I was little bit busy in managing all those things.
So for what purpose you got a call?
For PhD entrance exam.
Oh, great. Actually, yesterday I was missing you. No one was there to interact with me like you.
I'm grateful, ma'am.
So even I asked twice, I think, where is Biswas ma'am today? Fine. So I think today it will be like last session and ma'am will complete all what we have missed yesterday, right? So
Yes, ma'am.
so with this note, I'm starting today's session. Today is the topic which I'm going to cover is the correlation, right, and regression. So starting with the concept of correlation, anyone who wants to say or comment on the correlation concept?
In correlation, we see the association between two variables. There is no IVDV. There are just two variables, which that is not a causal relationship.
Yes, very good. Thank you, Viswas ma'am. Correctly, ma'am said when I talk about correlation, it is nothing but it is telling us the relationship between two variables, right? So whenever you're interested to find whether two variables are related to each other or not, we are using the correlation concept, right? Then correlation is, or I can write it is, a building block in statistics. Why so? I'm saying this particular statement because in statistics, generally we are applying, or when we are going for the advanced kind of statistics. Say, for example, we need to perform factor analysis, or we want to perform regression, or maybe we want to perform some other statistical tool, which are generally known as advanced statistical tests. So in that case, you need to understand this thing, that somewhere you need to know this thing, whether your variables are having any relationship or not, right? So most of the concepts, or maybe some of the concepts, I may say, generally are based on the relationship concept of the variables, right? So that is why you need to understand this concept. So that is a very basic concept in the research or in the statistics, right? That is why correlation is getting, what I can say, or correlation is generally known as an important topic of the statistics, right? So that is the one thing. Second thing is, when we talk about correlation, here we need to know this thing, that which kind of variables we need to have to apply correlation. So the types of variables which are required to perform correlation is, so when you are having two numeric or continuous variables, in that case, maybe you have heard about the name as Carl Pearson's coefficient of correlation. Coefficient of correlation, right? This is the one thing. Second thing is, when you are having two ordinal variables, then we are using Spearman's rank correlation. Third thing is, when we are talking about two nominal variables, so generally we are using Kendall's tau, right? So the importance in the statistics is that you need to know which kind of variables you are having. If you are having the numeric variables, you will go for the Carl Pearson's coefficient of correlation. If you are having ordinal variables, you will go for the rank correlation. If you are having the nominal variables, you will go for the Kendall's tau test, right? Is it clear till now?
Ma'am, I have a question. I have read that for ordinal variables, we use Kendall taus as well as Spearman rho. If the numbers are large, then we will use the Kendall taus. And for the nominals and variables, we normally use the biserial, point biserial correlation. Am I wrong?
No, no, you're not wrong. You're also correct, ma'am. But usually, this is the basic understanding. Means when we're teaching these things to the students, generally we are saying this thing. Numeric variable or continuous variable are requiring calculation coefficient of correlation to understand the relationship. Ordinal scale variable are requiring these Spearman's rank correlation, and Kendall's tau, as you said, we can perform on both the scales, ordinal scale and the nominal scale both, right? But when we are having the weird combination, one variable we are having the numeric, one variable we are having the ordinal, in that case, that biserial correlation comes into the picture. Is it clear?
Yes, we also have phi correlation, correlation.
There are grammars, there are very other correlation also available. But broadly, on the basis of the type of same variables, right? Same means both numeric, both ordinal, both nominal. Generally, we can say this thing. Say, for example, if you are saying phi and all, generally these we are using for the effect size and all.
Yes.
Right? So in that case, we are talking about those things. But in context to the correlation, we are talking about these three majorly. Biserial also I can consider here in case of when we are having the combinations of different kinds of variables. Fine.
Actually, this this is new for me, that when we use two nominal variable, you are saying that we use Kendall taus. This information is new to me.
According to you, which test we need to perform then?
Two nominal variables we use for phi or tetrachoric. natural or
Chi
artificial?
also you can perform, no issues. And usually for nominal scale variables, we are performing chi-square test also.
Yes, ma'am.
So chi-square test is also there. But when I'm talking about the correlation, in terms of correlation, we are talking about the Kendall's law. But if we are having nominal scale variable, generally for the nominal scale variable, we want to find the association, not relationship. We are
Yes.
finding association in the because nominal scale variables are characteristics only, right? So in that
Yes.
sense, we can find the association into the two characteristics using even chi-square test also.
Okay, ma'am. Thank you, ma'am.
Yeah. So further moving ahead, talking about some new other things about the correlation. Here in today's context, I'll talk about the Carl-Pearson's coefficient of correlation, right? So we represent the this Carl-Pearson's coefficient of correlation using the small letter r, right? And there are various values of r. Anyone is having any idea the minimum or maximum value, or what is the value of standard values of the r?
-1 to +1.
Very good.
If it is more than 0.3, we call it significant. If it is less than 0.3, then it is negligible.
Yeah, just a minute. Because of minus, it is creating a problem. So I'm writing minus like this, right? So generally -1 to +1 is the range of r. R cannot be less than -1. It cannot be greater than +1. It is the range of r, right? In this range, the values of r generally varies, right? If I say, as ma'am said, some of the ranges of r, and accordingly, what is the interpretation of r? So if I say broadly, what I am teaching to the students is when r is less than equals to 0.5, we can call it as a low correlation, right? When r is less than equals to 0.7, or in some books you can find 0.75 also, you can call it as a moderate correlation. When r is greater than 0.7, you can call it as a strong correlation, right? And second thing is, as ma'am said, the range is -1 to +1. So according to the sign of r, so the sign of r decides
Direction.
direction.
Direction. Minus says it is inversely proportional. Plus says
Yes.
it's directly proportional.
Directly proportional. Yes. Thank you, ma'am. So I can say that the sign of the r indicates the direction of the relationship. So that way, other meaning which we can draw from the correlation is that correlation can help you for finding the degree. You can call it as a strength and direction, right? So with the help of correlation, we can understand two things: the degree of the relationship or the strength of the relationship between the variables, and the direction of the relationship between the variables. So the value is helping you, that magnitude of the r is helping you to understand the degree or the strength, and the sign is helping you to understand the direction of the relationship, right? So as you can see here, if it is 0.5, so you can say it's a low correlation. Below 0.5 is a low correlation, right? So if suppose it is plus 0.5, you will call it as a positive low correlation. Negative sign will tell you the negative low correlation. Likewise, you can read for some other values also, right? So that way, this is very important to understand that two things we can understand using the correlation, which is the strength or the degree and the direction, right? Is it clear till now?
For me, yes, ma'am.
Okay.
Yes, ma'am.
Yeah. Thank you, both of you. So, and I
Yes,
think
ma'am.
those who are listening to me, yes, thank you, everyone. So now further, if I go and I talk about one more thing about the correlation, which is uh, as when we talk about the Excel, right? Excel has some limitations when we talk about correlation, because once we are performing correlation using Excel, Excel cannot help you to tell this thing whether your correlation value is significant or not, right? Whereas when we have seen till now, when we are talking about P, ANOVA, etc., so we have seen generally we are getting the significant value, that is the P value we are getting. And if we are getting the P value, we are able to comment on the significance of the that is statistic, that is T statistic or the F statistics. But whereas when we talk about the correlation, that is the small r value, here you cannot comment on that whether the value is significant or not, right? So generally we are making our hypothesis like there is no significant relationship between variable 1 and variable 2, right? So in that case, when we are writing significant, right? So whether the relationship is significant or not, you can't comment, but what the value of R, you can say this thing, whether the relationship is strong, positive or something. But nothing you can comment that whether the relationship is significant or not, right? I think one more thing I forgot to tell you here. If R is 0, that means
No correlation.
no correlation. Very good, right? So this is the important thing about the correlation when we are talking about the Excel. But I think I'll try to resolve this problem for all of you. But we need to do some little bit manual things to understand whether the correlation value which we are getting is significant or not. Is it clear?
Yes, ma'am.
Fine. Now I'll talk about the term causation. So causation meaning is that cause and effect relationship, right? So when we talk about cause and effect relationship, that means we are very clear one variable will be your cause variable, other variable will be your effect variable. Means if you are making some changes in one variable, it is making impact on your other variable. If this type of study we are interested to do, so correlation says sorry for this because correlation cannot do that, because correlation can not assume that this variable is the dependent variable and particular variable is the independent variable, right? So other thing you can see in correlation, there is no variable treated as IV and DV. For correlation only we are having variables, whether we are having numeric variable, categorical variable or ordinal variable. Only that is right. But we cannot comment that means in correlation we are not comment this thing that particular variable is dependent or independent. Is it clear? If we want to do such kind of study, we want to understand the effect of one variable on other and all. So we need to go a step ahead and we need to perform regression. So regression is a tool which can help you to understand the causation or cause and effect relationship, right? Correlation can only tell you whether the two variables are related to each other or not, and if they are related, up to what extent they are related to each other, and which kind of relationship they are sharing with each other. This is all we can know using the correlation. For understanding the cause and effect kind of relationship, we need to go for the regression. Is it clear?
But when in regression also there is no true IV and DV. IV and DV is only present in true experimental design. In regression we says predictor and predicted variables.
We can name them, but generally the softwares are asking us provide your y variable, provide your x variable. So in that case, as in mathematics, we are reading out y is generally treated as a dependent variable, x is generally treated as an independent variable. So we are naming them like that because it is easier to understand for us.
Got it,
Otherwise,
ma'am.
there are so many names of independent. Regressor is known as, predictor is known as, output variable, input variable. So there are so many names of these IVs and DVs when we are talking about regression. Clear, sir? Clear, ma'am?
Yes, ma'am.
Yes.
Right. Fine. Moving ahead. Now, I think I was talking about the types. So there is various types of correlation available generally. Simple, multiple, partial, then linear, non-linear, then positive, negative, So these are the varieties of correlation available in statistics.
Ma'am, sorry to interrupt you, but
Just a
is
minute, ma'am, just a
partial
minute,
core
ma'am, just a minute, just a minute.
okay?
Yes, I'm back. Extremely sorry for the disturbance. Yes.
Ma'am, just a tiny doubt. That is partial correlation as same as the bivariate correlation, because there are certain softwares that ask for bivariate correlation
I
as
think
well,
I'll
right?
discuss. SPSS is asking for bivariate.
Okay, okay. You'll cover it,
I'm
right?
discussing
Okay.
the meaning, all of the meanings, and then we'll discuss if you are not getting clarity.
Done, done. Thank you, ma'am.
Yeah. So starting with the simple correlation, when we study two variables, right? So it is known as simple. Means we are having only two numeric, two categorical, or whatever it is. So it is known as a simple correlation, right? When we study more than two, it is known as multiple. Here, when we study few variables by keeping other variables constant, it is known as partial, right? Linear meaning is when proportion of change is same, it is linear. Vice versa to this, when the proportion of change is not same, it is non-linear. Then positive, when the direction of change is same, it is positive. When direction of same is when the direction of change is not same, it is negative, right? So if I say, suppose I am studying the relationship between the student marks and its, for example, the number of hours he or she studied, it is a simple correlation, right? When I'm saying I'm considering more than two variables, suppose the student's marks, number of hours he studied, maybe in home, number of hours he studied in the maybe school, and likewise. So that is a multiple correlation. When I talk about partial meaning is we are knowing this thing that there are so many variables available which can help us or to study the relationship, but maybe those variables are not available to us, or maybe in some due to some of the constraints we are unable to get the information. So we are assuming that these are the constant we are keeping in the environment, as mentioned in, we are generally talking about the experimental studies. So maybe we are making them constant, we are trying to make them constant variables using some of the interventions and all, and that way we are studying only few variables and we are finding the relationship among them. This is partial correlation. When you are saying the proportion of change is same, proportion of change is same meaning is if you are changing one variable by 1 unit, other variables also changing by the same proportion, it is known as linear correlation, right? When you are changing one variable by suppose 1 unit, but other variable is changing by some different unit, maybe 0.5, 2, 3, something like that, that means proportion of change is not same, it is non-linear. When you are increasing one variable, other variable is increasing. When you are decreasing one variable, other variable is decreasing, it is known as positive correlation. Similarly, talking about negative, when you are increasing one variable, other variable is decreasing. When you are decreasing one variable, other variable is increasing, means the direction will be different. In that case, it is negative correlation. As ma'am said, bivariate meaning is what? When you are studying only two variables, bivariate, bi. So two variables you are having, that is known as, maybe that you can call it as a simple correlation. Is it clear?
Got it. Yes, ma'am.
Yes, ma'am.
Fine. So this is about the types of correlation. Further, apart from, I think this is the very basic concept I discussed about the correlation. Now we'll move ahead and talk about the next concept, which is regression. So as I said, whenever you're talking about the first thing, causation or cause and effect relationship, you can say this thing that this is, or maybe you're interested to perform regression. Or in other words, you can see when you want to find the impact of one variable on other, you are talking about regression. Or when we want to predict TV, that is dependent variable, using independent variable or independent variables, we are talking about regression. Or when we are interested in modeling the DV using IV, we are talking about regression. So these are the some of the reasons or some of the concepts where we can apply the regression. More or less everything is same, but these are the different what I can say ways of expression. That way we can understand that in this situation you can apply the regression thing, right? Clear to everyone? I hope it is clear.
Yes, ma'am. Yes.
Yeah. So if I talk about modeling meaning is what? Again, the same thing. Means you want to set a equation between the variables, right? Suppose I'm saying we all have studied a straight line equation during our school times. In mathematics, I think till 10th, everyone has studied maths. Generally in the, what I can say, India, till 10th, we need to study mathematics. So I hope everyone has studied maths. And we all know the equation of the straight line. Generally we are writing it as a plus bx. Yes. Yes.
Yes, ma'am.
Yeah. So why is I generally write it as dependent variable. Usually I teach to my students, and students are not getting things or tough words very easy, right? So I'm writing it as a dependent variable. Maybe you can write it as a output variable also, right? Up to you what type of word you need to use here. A will be your intercept, right? B will be the slope and X will be the independent variable or input variable or regress or predictor, right? Clear? I think every one of us has studied this equation till in or during our school days. Yes or no?
Yes, ma'am.
Okay. So here, when I talk about regression, and what if I say when I talk about statistics? In statistics, the equation is little different. This is the mathematical equation. In statistics, there is one more term we are using at the right side, which is known as
Epsilon.
yes, epsilon or E, right? That is
Error.
error term or residual, right? Meaning is that when I talk about this particular equation, what this E is, as it is error term, right? So meaning is that because we are interested in the prediction of Y here, we want to keep, because A and B are the constant values, we can keep, because X is independent. Independent meaning is it is free to take any value, right? So you can, according to your what I can say convenience, you can set some value of the X, and then you want to see the changes in the Y, right? So some value is coming for the Y. That means you are predicting or forecasting that if X is this, Y will be this, right? But if you're doing a prediction, you need to also check whether whatever you're predicting, whether this is correct or not. That means there will be some actual value of Y also. Yes or no?
Yes, ma'am.
Right.
Yes, ma'am.
So suppose we are having advertisement, expenditure, and suppose sales, or maybe the marks of students and the study hours, right? So here, if suppose I'm interested to predict, if company is investing this much in the advertisement, what will company expect as a sales figure, right? So in that case, if suppose company is investing 1 lakh rupees per month in the advertisement, and now company wants to see what will or what changes will come in the sales. So in that case, suppose according to the equation, suppose we are having some value of A, some value of B, and we are putting 1 lakh as the X value. We can multiply that by the B value, and then we will add that in the A. So we will be having the value of Y. So we can say this will be the predicted sales, right? Actually, suppose company has predicted the sales, or maybe the analyst who is working for the company has predicted the sales for the company. Suppose it is coming some figure, maybe it is 2 lakhs or something, overall in India or something, we are talking about 2 lakhs units. So maybe in terms of rupees, whatever it is, right? So that way, that is the prediction. But actually, suppose for that that prediction was done by a particular month. So now for a particular month, the sales were to be recorded by the company, and then we can make a comparison in the actual sales and in the predicted sales, right? If some deviation is coming, so that is known as error. So it is actual minus predicted or forecasted. This is known as error, right? If some deviation is observed by us, or if some deviation is coming, or some difference is coming in these two figures, we can say that is known as the error or the residual. Is it okay?
Yes, ma'am. Yes.
Ma'am, is it due to the outliers value?
It can be might be possible. There can be so many factors, ma'am, not outliers always. Say for example, you are saying we have invested this much into the advertisement, but due to say for example, today is the means right now there is a month of May, and in the month of May we are expecting a hot temperature or the very high temperature, right? But nowadays here where I'm residing in the MP, so here there is a rainy season. Means I don't know, suddenly from last 2 3 days to the last 2 3 days there is a rains pouring. So it is suddenly changed. So there can be some factor which can impact your sales. So you can't say this thing. External factors can also be there.
Got it, ma'am.
So
Ma'am,
these can,
ma'am, it can be said that E is basically unexplained variation.
yes, you can call them at that only, right? In technical term, you can call them as a unexplained error terms or whatever word you have said, right? You can call that also. There is no problem in that. But in the layman language, or in the very general people language, if I want to make you understand this thing, so that is a difference is known as error term, and there can be so many causes why the actual sales is differing from the predicted sales, because you are doing a prediction presently for your future. In the future, what circumstances will come, what situations will come, you're not knowing that, right? So you cannot keep those things. Maybe if you're having some idea, you can apply something that you can say, if suppose this is the prediction coming from us, so maybe in the next month these can be the things which can be probably occurring or happening. So maybe according to your being a company manager of a particular company, you can say if model is proposing 2 lakh rupees, or maybe 2 lakh units sold will be sold by our company. So maybe you can make some deviation from your side, because you're knowing maybe the future condition will be this. But model will saying this to you, that you can say that model is predicted this way. Now what will be the actual sales? You need to see the difference. That is known as the error. Is it clear?
Yes, ma'am. Yes.
So that unexplained variance also you can call it as, right? That can be caused by some external factors. Fine.
Yes, ma'am.
Yeah. Okay. So I hope this concept is clear to every one of you.
Yes, ma'am.
Now, there is types also of regression. Although there are various types, here I'm only talking about the linear regression, right? So that is simple linear regression and multiple linear regression. So when we say multiple linear regression or maybe simple linear regression, so here you will be having two variables. One IV, that is continuous or numeric, and one DB, which will also be continuous, right? In case of multiple linear regression, we will be having 1 dB continuous and more than 1 IV continuous or categorical or maybe both, right? Clear to everyone?
Yes, sir.
Done. So I think this is about the concept. Now talking about the hypothesis. So there are various ways of formulating hypothesis. Maybe we can write there is no significant impact of IV on DV, right? There is no significant influence of IV on DV. IV is not making an impact on DV. So that way, these are your ways of formulating the null hypothesis. Clear? And vice versa to this, you can make the alternative hypothesis also. So this is about the very basic concept of the this regression. I hope it is clear to everyone.
Yes, ma'am.
Yeah.
Yes, ma'am. Yes.
Fine. Thank you so much for the confirmation. Now I think we'll go and we'll perform the correlation using the Excel. So I'll expect you to open the sheet named as correlation. I hope everyone is having the sheet. Has opened, everyone? Shall I start?
Yes, ma'am.
Fine. So expecting everyone to open the sheet. If you have opened, you can find here we are having two variables listed named as temperature in Celsius and the sales of ice cream, right? Now, as this is a summer season, we know generally this thing that when temperature increases, generally the sales of all the items which are generally cold or which are generally giving us pleasure, generally the sales of them is increasing, right? So here we want to see whether when the temperature increases, sales increases or not, or when temperature gets down, sales decreases or not. This is the concept we want to opt here, and we want to see the relationship in these two variables. So first thing is you need to formulate your hypothesis. It will be there is no significant relationship between
Temperature and sales.
and sales of ice cream. Very good. Thank you, sir. Done? Done? Hypothesis we made.
Yes, ma'am.
Fine. Now there are two ways of getting the correlation value. So both the ways I'll try to explain you, right? The first way is there is a function, inbuilt function in the Excel. Using that you can find this. Put a equal sign, type COR. You will be getting this function CORREL, correl. Then this is asking you to provide the array. That means the ranges of your data you need to give. So select your first variable, temperature, put a comma, and select second variable and put a comma. And close the bracket. I hope it is clear.
Yes, ma'am.
So may I press enter? Yes.
Yes, ma'am.
Okay. I hope everyone is getting 0.75. Yes.
Yes, ma'am.
So it is a strong positive correlation, right?
Yes, ma'am.
Now, problem is you are not able to comment whether the relationship is significant or not. Although the value is very high, so it is quite obvious it will be a significant correlation, but we are not having any proof to comment on this, right? So that is one what I can say the drawback. Second is now we will talk about the second way of getting the correlation. So for that you need to go to the data tab, click on data analysis toolpack and select correlation. I hope everyone has found this located. So may I click on OK? So may I click on OK?
Yes, ma'am.
Yes, ma'am.
Yes.
Fine. Now you need to select your variables. So I'm selecting the range of the data, right? Done.
Yes, ma'am.
Data is in the column form. By default, it is taking groups grouped by. So our data is in the columns. So we'll go with the columns only. Labels I have selected because my range is B1 to C11. So I hope the same range you are having. So in that case, I'll select the labels in the first row. Done.
Yes, ma'am.
Now output range up to you where you want to generate. I'm generating on a same sheet. And then I'll click on OK. So I hope I can click on OK.
Yes, ma'am.
So here you can find we are having the metrics available of the correlation where you can find temperature and temperature. In the same variables, correlation will always be 1. Similarly, sales and sales. In the same variable, correlation will be 1. But when we talk about sales and temperature, the correlation is coming as 0.753389. Clear? Same values we are getting, but in this case also we are not getting the p-value. Clear?
Yes, ma'am.
So for understanding of or getting the p-value, I have given you the t-test. So when you talk about the correlation, for getting its significant value or getting its p-value, you need to have the t-value. T-value using this particular formula, right? So there you can find this t says t is equals to r into square root of n minus 2 divided by square root of 1 minus r square. So one by one, we will calculate all these things and we'll get the t-value. And using that t-value, we will get the p-value, right? So I hope I can start and it is clear what I said. Or do I need to repeat anything? Yes. Shall I proceed?
Yes, ma'am.
Yes, ma'am.
So if I talk about the numerator of the formula, so which is equals to r into square root. of n. N was 10. 10 minus 2. Done? Everyone, it is fine?
Yes.
Fine. You can calculate n, sorry. So n is what? You can count how many pairs of observations you are having. That is 10, right? So I think I have only calculated, only looking at my data, but that way also you can count or you can get the n value. It is okay? Numerator, everyone has got the same. So here, this time, if you want to provide this, that also you can do. Okay? Done? May I go ahead? Friends?
Yes, ma'am.
Fine. Now we'll calculate denominator. Denominator says square root of 1 minus r square, means r into r. Done? Okay?
Yes.
So may I press enter, everyone? Yes, please confirm.
No, ma'am, I have a problem. Can you
Okay.
please show me equal to sir?
Done?
Got it, ma'am. Done.
Fine. Everyone has got it?
Yes, ma'am.
Okay. So now we'll get the t value, t statistic value we will calculate, which is nothing but which is the ratio of your numerator and denominator. Done? Done, everyone?
Yes, ma'am.
So I hope everyone got the t value. Now we'll calculate the p value. Shall I start?
Yes, ma'am.
So t dot this dot rt, I think we have already read this, studied this in the session of t. So this is we are using to get the p value, where you need to pass x. X is your calculated p value, which is this, comma. Degrees of freedom will be 9. 10 minus 1, that is 9. Done? Got it, everyone?
Yes, ma'am.
Okay, so I think
Yes,
I can press. Yeah. Thank you, sir. Thank you, ma'am. So this is the p value we are getting. Done? 0.005. Yes.
Yes, ma'am.
What we comment on this? Yes. What comment we can do on this?
Reject H0.
rejected. Yeah.
It is less than 0.05. We can reject the null hypothesis, and we can say there is a significant relationship between the temperature and the sales of ice cream. Yes. Was simple, right? Is it okay?
Yes, ma'am.
So I think, yeah, it is done. So I think it is very simple to perform correlation using Excel. We did it. Now, next sheet is for the practice purpose that you can use. Now I'll open with the next sheet named as regression. Shall I proceed?
Yes, ma'am.
Okay, just a minute. I think I have performed in some other classes, so I need to delete this. Yes. Fine. So this is also, I think I have shown to this. Just this is the data set given to you, right? Fine, everyone?
Yes, ma'am.
Fine. So here we are having month-wise COVID cases and masks sold, right? For entire 12 months, data is given to us. So the first thing which you need to understand in the regression, because in regression clearly you need to know which is your predictor variable, which is your predicted variable, that you need to clearly state. So looking at the data, we are having COVID cases and masks sold. So which variable I can take as a dependent and which variable I can take as an independent? Anyone?
IV COVID cases, DV marks sold.
Very good. Fine. Sale of mask is depending upon the number of COVID cases occurring, right? So it is quite obvious mask sold can be the dependent variable and the COVID cases will be the independent variable, right? Now, if it is clear to us, next thing is we need to formulate the hypothesis. If we are interested to know if these will be the number of COVID cases, so what the number of mask sold can be, sales can be expected by the company. So here we can write there is no significant impact of number of COVID cases on sales of masks. Done.
Yes, ma'am.
Vice versa to this, your null hypothesis will be, alternative hypothesis will be, there is a significant impact of number of COVID cases on sales of masks. Done.
Yes, ma'am.
Yeah, ma'am.
Yes.
So shall I proceed?
Yes, ma'am.
Yeah. Now we'll go to the data analysis toolpath. We'll go down and we'll find regression is listed here. So you need to locate this and click on OK. Once you are clicking on OK, you will be landed on the regression dialog box. I hope till here everyone is with me. May I proceed?
Yes, ma'am.
Yeah. It is asking you input Y range. Y, as I said, it will be your dependent variable. So you need to provide the dependent variable here. So I'm selecting the mask sold range, which is E1 to E13 in my case. You need to check in your sheet what is the range.
Yes, ma'am.
Next is input X range. You can select number of COVID cases or COVID cases column, which is D1 to D13.
Got it, ma'am.
Then select labels. As I selected both the headings of my column, so I'm selecting this checkbox. Constant is 0, that is A, because in our equation y equals to a plus bx, constant A is a constant, right? So we do not want to make A as 0. We want some value for A, so do not check this box. Confidence level means by default it will give you the results at 95%. So I think I'm not making any changes. Output, I'll select this particular option and then a particular cell reference I need to give here. So I have given a cell reference where I want to get my output. Done.
Done, ma'am.
If further you miss till this particular point, if you will go with this particular dialog box and click on OK, even then you will get the output. But if you want to test your assumptions of the regression, because every statistical test are having certain assumptions in statistics. If you want to check the assumptions of regression, you can click on these. These will give you some of the graphs, right?
Yes, sir.
So if you want to check them, so residuals and standardized residuals, I think these are nothing. I'll tell you how you can calculate this also. Don't check first two. Check only the plots, these three. Done? May I click on OK? Yes.
Yes, ma'am.
Yeah. So you will be getting certain graphs. So you can shift them somewhere so that you would be able to read your output. Done?
Yes, sir.
Just a minute. There is some problem. I need to shift them one more time. I don't know where they went. Maybe they will come. Okay. Firstly, we'll talk about this output. First output we are getting as a summary output. I hope I can start with the interpretation.
Yes, ma'am.
Yeah. Now you can check if I talk about the interpretation part. In the first section, we are getting the statistics, regression and statistics. So there we are getting some of the important things. First one is the multiple R. Multiple R is what? It is your correlation value. Generally, this is a term fed there in the memory of Excel. So it is nothing but it is a correlation value, which is coming as 0.98, which is a very high value, very near to 1, right? That means you can say there is a very strong positive correlation between the COVID cases and masks sold, right? Is it clear? It is indicating strong positive.
Yes, ma'am.
Right. R square and adjusted R square. There are two terms, R square and adjusted R square. So once you're talking about the simple linear regression, so you will use this. In case of multiple linear regression, you will use adjusted R square. So here our case is the simple linear regression because we are having only two numeric variables. So we are talking about the simple linear regression, right? So in that case, what is the meaning of this? R square and adjusted R square interpretation is same. Only thing is that which you need to report when, that is important. In case of simple linear regression, I suggest go for the R square. In case of multiple linear regression, go for the adjusted R square. Means once you are having the multiple independent variables, in that case, go for the adjusted R square. Okay. Now the meaning. Talking about the value of R square, which is 0.96, again, which is very high. So you can say this thing, that is 96% variance in DV, that is mask sold, is explained by IB, that is number of COVID cases, right? Means how much percent change in your dependent variable is explained by your independent variable that we can understand using the R square value. So approximate 96% changes in the value of the mask sold is explained by number of COVID cases. Clear?
Clear, ma'am.
Yes, sir.
Done. So adjusted R square, we are not interpreting here, but you need to always know this thing. Always your adjusted R square will be lesser or maybe equal to your R square. There will, it is like R square will always be the larger figure than the adjusted R square, right? Standard error, it is 141. There is no threshold for the standard error, right? Total observations, we having total 12 observations. Next come as the ANOVA table. ANOVA table is again playing an important role in case of regression. There is, you need to see the significance value, which is 2.43153 E minus 0.08. That means this value is less than 0.05, right? So if it is less than 0.05, that means your model is significant or model is good fit. Means whatever prediction you will do using this model, that will be a good prediction. This is what you can comment using the ANOVA significant value. Is it clear?
Yes, ma'am.
Further, the last table in this particular section is the coefficient table, which can help you to formulate your model or your equation, right? There you can find we are having the coefficient value, which is minus 245.631. It is intercept value, right? COVID cases, coefficient value is 0.994556. That means this is the B value, because coefficient of COVID cases will be the B or beta value, right? Which is 0.994556. But before reporting these two as an equation or as a model form, you need to ascertain this thing, whether these two are significant or not. So how you can ascertain that? Looking at these two things, because in the case of regression, we are also getting the T statistic and its P value. So the role of this T is that, or its P value is that it will help you to confirm this thing, that these two, that is intercept and the coefficient of your independent variable, are significantly contributing to your dependent variable or not. So you need to see these two are significant or not. So looking at the P value, you can see for in case of intercept, and similarly in case of the coefficient of COVID cases, you can find. So can anyone tell me whether these two are significant or not?
Yes, ma'am. Less than T stat.
Yes.
That means significant.
Yes. Thank you, ma'am. So both are less than 0.05. So we can comment that these two are significantly contributing to your dependent variable, right? Further, 95% lower and upper case or as if you have seen 95% confidence levels. These are the two ranges we are getting, right? So chances that if we are picking the data from the same sample, intercept value or chances of intercept value will falling in a particular range will be this. The intercept value will be coming between this range. Similarly, in case of COVID cases, you can say 95% chances are there if you are taking data from the same population. The chances are there that the COVID cases coefficient will fall in this particular range, right? Is it clear?
Yes, ma'am.
Yes.
Now we will make, now we will make the equation or model, which is y equals to a plus b into x, or you can say it is mass sold equals minus 245.631 plus 0.99 multiplied by number of COVID cases, right? So this will be the equation. Fine. Clear, everyone? So if we are having the figure of number of COVID cases, we can put here, we can multiply that by 0.99 and we can subtract this intercept value and we can predict the sales of masks. Is it okay?
Yes, ma'am.
Fine. So this is the residual values which we are getting here, right? This is the probability output we are getting here. That what are the chances, percentile values we are getting here, right? Now you need to see, if you want to calculate all these, you can calculate also by your own. How? I think you know this thing. We are having the model value. What is your model? It is minus 245 plus, I think point something it was there, right? 0.63 plus 0.99 into the number of COVID cases. This is your equation, right? Why? This is taking minus, because of minus this problem is coming. Fine, fine. Now, if I'm coming here, I need to predict. So what I'll do, I'll do one thing, select once this, intercept, right? Plus, select this, multiplied this by the COVID cases. Fine?
Yes, ma'am.
So this is the prediction you are making. And then you can drag till the last. You need to make them constant first, just a minute. Using the F4, you can do so. Done? So this is the prediction. This is the prediction done by your model. Now you can see the difference. That is actual minus predicted. Right? Fine. Which is equals actual is this minus this. So this is the error term. Fine, everyone?
Yes, ma'am.
And you can find the same output is generated by the Excel also. You can cross check this. Same values we have calculated here and same we are getting downwards also. Fine, everyone? I hope it is clear. I hope I'm clear, everyone. Was it okay?
Ma'am, for me, some values come bizarre.
Okay.
Like in case of the your F value, can you
I
show me the
think, yeah, I think it is
F
coming
column?
because, yeah, because you need to make these things absolute, right?
Got it, ma'am.
You
Got
need
it,
to
ma'am.
freeze them. That is why it is coming.
Got it, ma'am.
Fine.
Both for the okay. Got it, ma'am.
Now drag and see.
Got it, ma'am.
Fine. And the difference is, I think, easy to understand. It is actual minus predicted only. So this is your prediction, which you have made. You can make it as a predicted column or prediction. So the difference of these two will give you these figures. These are the error terms, right?
Got it, ma'am.
Yeah. What about others?
Yes, ma'am.
Clear, everyone? Coming to the graphs. Where were my graphs? There is some problem in Excel. It happens many times. My graphs. These are visible, na? Where were they?
Sometimes visible, sometimes gone, ma'am.
Yes, yes. Normal probability plot, if it is coming, it is telling you whether your residuals are normally distributed or not. Where it is, how I can tell you that. What happened? Sometimes it behaves like this only. See,
Ma'am, I thought it goes behind your table. That's why it shows like that.
in your case, it is visible.
Yes, ma'am.
Okay, what about others? Anyone who can share his or her screen, otherwise I need to check again. Do I need to perform or what? I need to check that.
Ma'am, I can click the picture and send it to WhatsApp.
That is not easier for everyone to understand. No. See, now you can see. What happened? I'll change and again generating just a minute. Visible?
Yes, ma'am.
So I'm not making any changes here. I'll try only to stretch it so that you can see. Yes. Normal probability plot is the plot which can help you to understand whether your residuals means here when we talk about regression, here regression is bothering about whether your residuals are normally distributed or not. So this should be generally you can find this should be when you are looking at this particular diagram or the graph you can see this is the distribution of the residuals. Visible? I hope visible.
Yes, ma'am.
Yes.
Yes, ma'am.
So this should be a straight line usually. This line should be a straight line. Almost you can see or you can say this thing. The line is almost straight, right? Or you can do one thing just a minute. Oh. It is difficult in my case to do so. Are you able to do? Are you people able to perform what I did? Are you able to add a trend line here or not?
Yes, ma'am, I can.
Fine. So if you're able to find or fit a trend line, you need to see if all the data points are exactly following the trend line. It is good. Means if the deviation are very less, that means you can comment approximately your residuals are normally distributed. But when the deviation is very far, means some of the data points or some of the residuals are going very far from your fitted line. That means there is a problem. Clear?
Clear, ma'am.
Yes, ma'am. Yes.
I'll try to put this here. I hope it is okay. Yeah. Now the COVID, what happened? Yeah. Now you can see COVID cases line fit plot. So here you need to see the predicted value and the actual value. So here the blue one is the actual values of mass sold and this orange one is the predicted value of the mass sold, right? So almost they are coinciding, right? But still at some point you can observe some deviation in the actual and the predicted value. Is it clear?
Yes, ma'am.
Same.
So I'll keep it here. Now I'll come to the next. Right. Here, COVID cases residual plot you need to see. In this case, you can see a middle line and which is the zero. You can find this axis is zero axis, right? So the distribution of these points, data points, which is shown in the blue color, these should be equally distributed both sides. Proportion should be same approximate, right? Second thing is that this is generally indicating that there is variance is constant of your residuals or not. So variance should be constant that you are ascertaining using this particular chart, right? So if the proportion is same of the residuals at both the sides, somewhere you can comment that the variance of the residuals is constant or same or homogeneous variance is there. One way is this, other way is this. You can see if you are able to see some formation of any particular shape in this particular graph, like cone shape. Cone meaning is all what I can say, these points are forming some shape like cone. Cone, I think everyone knows, like this, right? So this is a one case. Apart from that fan type of shape is you are able to see. So some of the shapes which are very prominent in this case, if you are able to see that your restaurants are forming some kind of shape, in that case you can say the variance is not constant or variance is not same. Is it clear? But in our case, we can say there is a scatteredness in these points, and almost equal points are distributed at the upper and the below zero, above and below zero. That way you can comment that variance is approximately constant. Fine.
Here we can see the sine curve.
No, not sine. Fan, cone, etc. Not sine.
Okay.
Fine. Is it okay?
Okay, ma'am.
Now next is the multiple linear regression. So open the last sheet. Next sheet is for the practice purpose. For your purpose, you can use it. And now open the last sheet, which is the multiple linear regression. Open.
Yes, ma'am.
Shall I start?
Yes, ma'am.
So yeah, so here rather than giving you the name of the variables, I have kept it very simple. We are having y variable, which is your dependent, and we are having two independent variables, right? Now we need to find the regression among these. As you can see, one dependent, which is numeric, and two independent variables are available with us. So we can go for the multiple linear regression. So to perform multiple linear regression, we are having the same option. Go to the data analysis and select the regression and click on OK. Right? All things are there, so you can remove all the changes. Right? Fine. Come to the first section, which is asking for the y range. So you can select the y variable. Done. D1 to D11 is my range. Friends, done.
Yes, ma'am.
Now for the x variable range, you need to select your, come to the box and select both the variables column. So range is D1 to C11. Done.
Yes, ma'am.
Labels, I think I have selected labels by default. Not by default, already we have performed simple regression. That is why this checkbox is checked. If in your case it is not checked, so please select this if you have selected your labels of the column, right? Same, I think I'm not generating all these right now. We are keeping it simple. Coming to the output range and select this particular blank cell, whatever cell you want to select as a blank cell to get the output, select that and click on OK. So may I?
Yes, ma'am.
Done. Got it? Shall I start?
Yes, ma'am.
Okay. So starting with the multiple R, that is multiple correlation, which is 0.8367. So combinedly in all the three variables, the correlation is coming as 0.8367, which is again a strong positive. Now R square we are not interpreting as it is a multiple regression. So go for the adjusted R square, right?
Yes, ma'am. Second again.
Now here again the explanation will be same, which is you will write it is approximate 61% of Y is explained, or 61% variance in Y is explained by both x1 and x2 variables combinedly. Then means combinedly your both the independent variables are explaining
Yes,
or
ma'am.
making
Yes,
change around 61% change in your Y variable or in your dependent variable. Then
yes, ma'am.
Yes, ma'am.
yeah, and total observations we are having 10. Coming to the next significant value you can find here, which is less than 0.05. That means model is a
80 digit.
yes. That means we can say model is a good fit, right?
Yes, sir.
Coefficient values, if you will see, these are the three different values of the constants we are getting. Intercept, that is a or maybe alpha. X1 and X2 constant or the coefficient, which is minus 0.81 and 2.41. Now you can ascertain whether these are significantly contributing to your dependent variable or not. So looking at the p-value, what comment I can do? Yes,
Significant, ma'am.
significant.
Less than.
Yes. Very correct. Thank you so much, ma'am. All three are significantly contributing to interpret or to predict your dependent variable. So you can write y equals to 43.1092 minus 0.81815 multiplied by x1 plus 2.01772 multiplied by x2. This will be your model or equation, right? Clear?
Yes, ma'am.
Fine. So next sheet you can use for your practice purpose. If I want to summarize the session here, and then we will take some of the situation, 2-3 situation. I think time is there, 5-10 minutes we are having. So I'll summarize the session today. We tried to understand the concept of correlation and regression. We have understood what is the difference in correlation and regression. Correlation can only tell you the relationship between the two variables, or that relationship will be in the percent form, because it is telling you the extent of the relationship. Whereas regression is also telling you the relationship, but that will be the algebraic relationship between the two variables. Because we are explaining that in the equation form, we are easily not easily means we can try to find the magnitude in the change of one variable by making change in the other variable. That we can do using the regression, right? And then we have understood the concept of causation, and why causation is or correlation is not a causation, that also I tried to explain you. And then we have seen that causation type of study, if we want to do, we can go for the regression, right? We have seen when we talk about correlation can apply using two ways in the Excel. One is the function, second one is the data analysis toolpath. But in both the ways, we are not getting the significant value. So for the purpose, I introduced a t value, and then we have found the p value using the value of the t. And then I said using that value, you can comment that whether the correlation which you are getting is significant or not. One more thing I think I forgot to tell you. One more way to understand the relationship between the two variables is the graphical way. That is using the scatter plot. So if you want to do that, you can select your variables and you can go to the insert. Right? In insert, you can find in the third row, second option is this, that you can select. So that way also you can understand the relationship kind of thing between the variables. Right? Is it okay? This is one more ways I think I forgot to tell you. Some more things we can do in this. But that way also you can tell or comment on the relationship type of your variable. This is what we have seen in case of correlation. Then I tried to explain you regression concept, and we have seen how we can perform simple and the multiple linear regression using Excel, right? So we try to interpret the results. We try to make our equations and formulation. I also told you manual way of calculating the residual values, and how you can use your inbuilt or not inbuilt your formulated model to predict the dependent variable. This is what we did till now using the Excel. So I hope any queries are not having. If you are having, you please ask. If not, we'll go for some of the situations. Yes. Any doubt in the today's topic? Yes. So silent you people are. Why so? I hope you people are listening to me. I think I'm there in a meeting.
Yes, ma'am.
Yeah. Any doubt?
Yes,
Any doubt to anyone? Okay, so I'm
No, ma'am.
assuming, yeah, I'm assuming it is, there is no doubt. Fine. Give me a second. I'm sharing my next sheet. I hope it is visible. Visible?
Yes, ma'am.
I'm expecting you please spend few seconds by on reading of this particular situation and then tell me if this is a situation which test you can apply on.
I think it's another.
Sorry, one answer I think it someone said chi-square. One I think I heard ANOVA. Is it right what I heard?
Yes, ma'am.
Fine. So may I know who said which one?
I said ANOVA. I think I got wrong.
Biswas ma'am said ANOVA. No issues. Okay, the other person?
Ma'am, Dr. Manjeet.
Anova,
Manjeet ma'am. Manjeet ma'am said it's chi-square, right?
Yes, ma'am.
Fine. Okay. Any other opinion?
Regression analysis.
Okay. Okay. It's a regression. Savan sir is saying okay. Okay. Any other options or any other opinion you people are having?
Ma'am, it's chi-square.
Okay. Okay, Viswas ma'am, you have changed your mind. Fine. So I think I'm commenting. I'm putting my opinion. I think it is a case of chi-square because you can find here it is clearly written we are having some percentages for different categories of movie genre, right? And we want to see this thing whether there is a significant difference coming in the observed and the expected genre preferences. Yes or no? So that means we are having nothing, but we are having generally we can say it's a count kind of thing, right? And that way these percentages were calculated, and we want to comment whether the observed percent and the expected percent or the number are different or not. Is it fine?
Yes, ma'am.
Fine.
Yes, ma'am.
Shall I proceed for the next?
yes,
Yes, ma'am.
Yeah. I hope it is visible.
It's t-test. Dependent pair t-test.
Okay, fine. Any other opinion?
ANOVA, ma'am.
ANOVA, okay. Uh, any other comment? Any other opinion? Okay. So Manjit ma'am, which ANOVA you are expecting here? Yes, Manjit
Ma'am,
ma'am.
not sure, ma'am.
Okay, not sure.
Yes, ma'am.
Okay, no issue. But I think you have guessed it correct. We will go for the ANOVA only. Viswas ma'am, what you said?
Pair t-test.
Why so?
Because maybe there is two variable with two levels.
There are three variables. See, a company offers three different training programs: technical, leadership, and the sales. and has two job roles, manager and staff, right? They assess employee performance improvements after the training. The company wants to analyze whether the training program and the job role affect the performance and whether there is an interaction effect between the training program and the job role, right? That means we will be having job roles, means manager category people will go for the training, staff category people will go for the training, and these are the three different types of training will be provided to them. So then performance will be recorded. The person who has taken technical training belonging to the manager category, what is the performance value of them, right?
Actually confused, right? What the two variables are? Training program is one variable, job role is another variable,
And
and
both
there
are
is three
categorical.
levels,
Yeah, and both
three
are
levels of
categorical.
training program: technical, leadership, and sales. Maybe
Right.
for that reason I confused it.
Yeah. So that means we are having two categorical and one numeric variable. Right?
Yes.
And the interaction, if we want to see, we'll go for the two-way ANOVA. We will firstly see the individual impact of these two independent variables, whether the training program is making any changes in the performance or not, whether the manager category, whether the job category is making any changes in the performance or not. And then when we are considering the job role and also the type of training program given, whether this is making any impact on performance or not. Clear?
Ma'am, can you tell me once more what are the variables here?
We are having the type of training program and we are having type of job roles and we are having the performance value. We want to see the
Okay, got it, ma'am.
performance, right? Clear?
Clear, ma'am.
Okay, ma'am.
So the last problem I'm taking for the day, this is the last situation I'm taking. Please read it and then comment.
Independent teachers, ma'am.
Which one? Independent?
T-test.
Independent test. Okay. Any other opinion?
I think regression, ma'am.
Okay. Okay. Any other opinion? One T, one regression. Any other opinion? It is a case of one-way ANOVA.
I think I have to see the ANOVA recording again, ma'am.
Yes, yes. Reason is that you can see problem is saying a company is experimenting with the three different work schedule. So we are having a work schedule and there are three categories. So it is quite obvious it will not be independent details because in the categorical variable we are having three labels. For each different work schedule, we are assigning, a company is assigning 60 employees, right? So whatever are their productivity values will be recorded there. So 8 hour, if the schedule is 8 hours, so productivity value will be given. If the what I can say schedule hour is 10 hours, so the productivity values will be given, and likewise for the 12 hours shift. So that we need to see which in which particular shift the mean productivity is better. Is it fine? Is it okay?
Got it, ma'am. Got it, ma'am.
Yes. So this is a case of one way ANOVA. Clear?
Yes, ma'am.
Fine. So I think this is all from my side. I can say finally for today's session and for all the 5 days which I tried to explain you or deliver you the content. Thank you so much for your patient listening to me and performing along with me, hands-on doing along with me. Thank you so much, everyone. I wish you all the very best for your future endeavors. So I think this is all from my side. At last, I want to ask you for one thing. If you can switch on your camera so that I can capture you all. If it is
Ma'am, I have a question.
yeah, please.
Ma'am, is there any possibility that you teach our analysis for the statistics?
Our
Our language analysis, yes, our software.
I teach usually the RFI conduct some of the programs on R, and generally they invite me for the same. So in future, I don't know, but we need to ask to the RFI for the same.
I already asked in the group because I'm interested in learning our language.
Yeah, so I think maybe in future if they are planning to what I can say schedule these things, they will put the information in your WhatsApp group also. So you be there in a WhatsApp group, right? Yeah, I think now you people are ready. I can capture you all. Thank you so much. So I think I captured 4 5 people. Just a minute. One more person has just switched on the camera. 2 people. The Manjeet ma'am and the Marak sir. Thank you so much, everyone. It was nice to looking you all. Since last 5 days, I was feeling like I'm interacting with camera only. So thank you so much for switching on the cameras. I can see your pretty faces. Thank you.
Thank you, ma'am. Thank you.
Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, everyone.
Thank you, ma'am.
Thank you. Thank you, everyone. So over to you, Yogra sir. We are done for the day. Thank you, sir. So I hope I can leave the meeting, sir, now.